Hello and welcome to this short presentation on the design of the new Gourock Dunoon passenger ferry. My name is Andy Crossan and I am the vessel project lead on behalf of CMAL. Again, thank you for joining this presentation. Please check out the dedicated Gourock Dunoon programme page on the CMAL website for all information relating to both the vessel design and the infrastructure projects. The overall project has been managed by CMAL with marine and civil engineering support provided by Mark MacDonald. The concept vessel design is also managed by CMAL's vessels team with support from BMT specialist ship design consultants. This project is part of a wider programme of works chaired by Transport Scotland. The order of this presentation will be design consultants, current and previous vessels, project phasing, parametric study, hull design, recommendations and the next steps. The appointment of design consultants. The first phase of the project saw the appointment of BMT specialist ship consultants to support CMAL in the vessel concept design. This process was conducted through an open tender exercise under Public Contract Scotland. As can be seen from the slide, BMT bring a wide range of experience in the world of design and consultancy, with a specialist arm of the group dedicated to ship design based in Southampton. BMT's design portfolio covers a wide range of vessels, dual fuel, conventional, fast speed and futuristic. Current and previous vessels. One of the current vessels, the Argyll Flyer, she's a monohull, length of 30 metres, a beam of 7. She has a maximum speed of 19.7 knots, however with restrictions on the service she operates at 12 knots. The second vessel deployed on the service, the Alicat, she has a length of 19.5 metres, a beam of 8.3. She has a maximum speed of 14 knots, again restricted to 12 knots, and she is a catamaran construction. As I'm sure most interested parties are aware of, the previous type of vessel deployed on the route being a streaker type such as the Juno, Jupiter, Saturn. This being a passenger and vehicle ferry with a capacity for 38 cars and over 500 passengers. It's estimated that to replace such a vessel today would be in excess of £30 million. So why the need for change? It's clearly recognised that today's vessels do not fit the current and future expectations of the service, with a clear goal of this project to provide a reliable and resilient service for all commuters travelling on the routes between Gourock and Dunoon. But how do we do this? Well, the project first looks at how we can increase resilience and reliability of the service itself. We improve seakeeping, address mechanical failures, improve manoeuvrability, improve accessibility for all travelling passengers, address environmental considerations, and look to reduce operational costs. However, we need to understand realistic expectations. The current category for the area of operation on the Clyde is specified as Category D waters. This means that the vessel design as a minimum must be capable of operation in significant wave heights of up to 2 metres. It's vitally important that the project sets, understands and attains these realistic expectations, and also that the travelling public also realises the constraints of the service as determined by safety, operational and commercial influences. This way, a collective approach can be taken forward. Review of available data indicates that vessel cancellations out with mechanical failures can be attributed to weather-related incidents. Again, it's important to understand that this can be attributed not only to the vessel's ability to make the crossing, but also the ability of the vessel to berth safely at Gourock and Dunoon and to allow passengers to embark and disembark safely. Project phasing. and how we start on the journey of dealing with the challenges ahead. The project has been split into 4 distinctive phases. Phase 1, Statement of Requirements, which takes on board the objectives set by Transport Scotland and Calmac. Phase 2, Technical Foundation, with this phase looking at the possible hull form and propulsion systems best suited to the service. Phase 3, Design Consolidation, which attempts to align all considerations and feedback from all stakeholders, including the general public. And Phase 4, Design Review, with this phase geared towards gaining agreement on the way to proceed and making recommendations on the best way to follow that process. Concept design and what that means. The journey through the concept design begins with identifying, firstly, the statement of requirements. With these requirements identified from a number of stakeholders and distilled into a working document by Transport Scotland and Calmac. This is supported by the outline operational requirements, which is led by the operator, Calmac, based on their knowledge of the service. And finally, these requirements are passed to CMAL to work alongside specialist consultants to develop a solution that can deliver against the Statement of Requirements. This particular slide provides an insight into the Statement of Requirements, which have been passed to CMAL in order to develop the ferry design. As can be seen, it identifies the weather conditions that the service will operate safely and efficiently within. Category D waters, up to 2 metres significant wave height, as identified by the MCA relating to the class of vessel to be delivered. It also identifies passenger numbers as 250 with minimum crew levels set at 3 and a service speed of 12 knots. These are just a few snapshots of the details that are contained within the Statement of Requirements. Item 4 is the Parametric Study. This is basically where we move from the Statement of Requirements that we've just touched on and move into the phase of how we can deliver against those particular requirements. Current progress, Phase 2. This is where we currently find ourselves in Phase 2 of the process, Technical Foundation. So what is a parametric study? Well, it's the study of the influence of the different geometric and physical parameters on the solution to a problem. And I'm sure we would all agree that the current vessels, the infrastructure and the climate in which the Gourock Dunoon service has to operate certainly presents such a challenge. So our study and the journey so far has looked at a variety of hull forms, monohull, catamaran, single and double-ended variants, up to and beyond 40 metres in length. We've considered criteria such as CAPEX, energy consumption, seakeeping, reliability, passenger comfort, passenger capacity, manoeuvrability, wake and wash, ease of maintenance, draft limits, accessibility and safety. This then allows us to develop a concept with regard to weight and powering of the hull form. Within the parametric study, we move into CFD. This allows us to look deeper into wake field analysis at the vessel's service speed of 12 knots and beyond, and in turn allows us to develop and optimize hull form options. The parametric study needs many strands of input data, such as weather conditions, which play a major influencing factor on the design of the vessel. As can be seen from the slide, we have engaged with independent sources to evaluate weather conditions in the area of operation based on available data from 2011 through 2020. This data identified that a mean significant wave height of just under 1.5 metres was experienced during the winter period, aligning with the MCA evaluation. However, that being said, the concept design will be based on a minimum performance criteria of 2 metres significant wave height in line with the Statement of Requirements. The parametric study also considers seakeeping ability of the new vessel and again focuses on why the current vessels appear to underperform. The study looked at the adverse weather data and the inability to sail, along with secondary influences such as mechanical breakdowns. The design of the new vessel will strive to achieve redundancy in propulsion and in turn deliver greater reliability, and will look to develop a seakeeping motion which will afford a greater degree of comfort to the travelling public. This slide provides a snapshot of the detailed analysis that this entails. Passenger loading analysis. The passenger loading analysis proved to be very interesting, as the data available would indicate that nearly 80% of the time the vessel would sail with less than 25 passengers, with the exception being the weekend of the Cow Games, which we are all familiar with. As can be expected, the question of why design a vessel capable of carrying 250 passengers has been asked. The answer itself not quite as straightforward as it may seem. However, in general terms, the top-line influencers can be seen as future growth based on the provision of a reliable service, expansion of tourism to the Cow Peninsula, and the optimization of a hull form, which will provide a stable platform, again attracting more travelling public. This slide again provided as a graphical representation of a year-on, year-off passenger loading profile. So in general, the parametric study has looked at monohull configurations ranging from 30 metres up to and in excess of 40 metres. It should be highlighted that the study indicates that in excess of 40 metres, a significant cost increase with regard to CapEx, OpEx and emissions occurs, with no resultant gain with regard to performance. Again, as can be seen, the parametric study followed a parallel path in the analysis of a catamaran hull, covering 25 metres through to 40 metres. This slide attempting to provide an overview of the works undertaken. Hull design phase. In the hull design, it's important to realise that the key to success of this particular project doesn't lie with the vessel itself, as the infrastructure development at Gourock and Dunoon play an equally vital role in the delivery of a reliable and resilient solution. As in addition to a monohull and catamaran solution, a double-ended variant was also identified as having merit in this application due to the increased manoeuvrability and reduced need for swing around in port. A more detailed assessment of the merits and viability of double-ended variants of both catamaran and monohull have therefore been carried out. The assessment of the double-ended ferry also included initial arrangements, weight calculations and powering calculations, preliminary CFD to confirm powering requirements, review of potential propulsion units, Voith, Cyclo, Azipods and conventional, station keeping assessments to quantify increase in manoeuvrability, CapEx and potential future OpEx review. This slide is to give a representation of the assessment done between double-ended variants and single-ended, benefits being increase in manoeuvrability, vessel capability for station keeping, reduced manoeuvring space requirements, passenger embarkation, and no increase in overall crew numbers. However, disbenefits have to be weighed against increase in major capital costs, the potential for decrease in seakeeping capability, increase in draft limits, and potential increase in maintenance costs, just to touch on a few. So, conclusions at this particular phase of the project. The analysis has concluded that both monohull and catamaran variants in the range of 35 to 40 metres will satisfy the statement of requirements as set out by Transport Scotland and Calmac, with the double-ended variant providing some additional benefits with regard to entering or leaving port. However, this is offset by reduced seakeeping performance against a catamaran hull. The double-ended variant would have a substantially higher capital cost along with potentially higher maintenance costs. Recommendations and the next steps. Recommendations. Following the assessment of the range of catamaran and monohull models and through discussions with the working and reference groups, it is recommended that further work on the technical performance of both a double-ended monohull variant and catamaran in the range of 40 metres in length will be required. We are confident that this approach will contribute, along with the development of the port infrastructures at Gourock and Dunoon, in reaching the correct solution for the Gourock Dunoon service, which we look forward to sharing with your good selves in the future. The next steps. The next step will be to embark on the study of the energy architecture, options and available solutions, with an in-depth look into detailed selection of main propulsion units, hull forms, current and evolving technologies. It's clearly recognised by all of the project stakeholders that the key to this particular project's success doesn't just sit with one strand but relies heavily on all elements, fully integrated to provide the optimal solution. That includes the vessel design, the infrastructure, the operator, government and local authorities, funding, and most importantly, the needs of you, the travelling public. Programme. An indicative programme has been prepared which I am sure is of interest to all parties and is shown in the following slide. This all starts with feedback from your good selves following this presentation. Completion of the remaining phases of the vessel design project is scheduled for Q1 next year. That would then allow us to move into invitation to tender through the open procurement process in Q2 and 3 also next year, with a contract award to the successful shipyard anticipated as Q1 in 2023. The estimated vessel delivery following this process, bearing in mind that this will be driven by market availability, is estimated as Vessel 1 being Q4 2024 through Q1 2025, Vessel 2 Q1 2025 to Q2 2025, and finally Vessel 3 Q2 to Q3 2025. Finally, thank you for listening, and I hope that the information presented has been of interest. If you have any questions, please use the CMAL feedback form, which can be found on the CMAL website at info@cmassets.co.uk. Thank you in advance for your questions. We appreciate your time and look forward to meeting with you in person at future engagement events. Again, many thanks for your time.